Hello, everyone. Welcome to the Off by One security stream, our second of the year. Give it a moment for folks to join in, as always. But I'll go ahead and just talk about a couple of things. I'm working on identifying and scheduling some more guests to come on over the coming months. I've got a lot of requests on Discord from folks as to like some people they want to see or some topics they'd like to see covered. I think it'll be just me next week. I have some things to show. I won't share it yet because I don't know if I'll have it ready in time. So I don't want to overpromise and underdeliver. But definitely be on next week to do something cool. And then there's going to be, I've been trying to figure out a way since we haven't done a giveaway or anything major like that since DEF CON, where we sponsored a couple of people to fly out and attend DEF CON. It was really cool. Luckily, my talk was accepted at DEF CON, and I was able to give my guest passes to some people, which actually helped out a lot. Of course, we could help more people. I'm going to try and submit another talk this year. We'll see how it goes. I have to come up with something first, but cool. All right, let's go ahead and get started then. My guest this week is Mark Baggett. I've known Mark for, I don't even know how long. It's been that long, definitely well over 10 years. He is also a senior instructor at the SANS Institute and author of a couple of courses on Python. I'll let him kind of give a little shout out about those, but those are the 573 course and the 673 course. And he's definitely someone, you know how I don't know how to word this right. There's certain people who will say something like, oh, if this guy says this person is smart about something or knows something, I know they're absolutely telling the truth, or I have to believe that. Like this guy, Mark here, is absolutely an expert at all things Python. And he actually helped me out in the 660 course that I have. We used to have a Python module in there, and it was kind of getting old. And I asked Mark if he could rewrite it, and he made it a lot better. Actually, that'd be a cool thing to do since we retired that module from the course. Might be cool to actually run that module as one of the streams sometime. I don't know if you'd be down to do that, Mark, but you could help me, or I could do it myself.
Yeah, sure. I'm sure that you know the content in there backwards and forwards. But yeah, correct me if I'm wrong, but I think that module was in there really to prepare people for all of the fuzzing and things like that they were going to be doing in the upcoming modules. It wasn't that you were really trying to teach people Python. It was that you were trying to give them the fundamental skills that they needed just because you use Python in just about everything.
Yeah, that's exactly right. I mean, it's anytime you have a class and people come to take that class, you can put prerequisites all day long on the page, but not everybody reads them. I should say almost no one reads them. And a lot of times you'll end up with a class where half the people have the prerequisite knowledge and the other half don't. So we try to like do a quick intro module to get those folks up to speed, but also it's a balance of trying to make it also cool for people who already know Python. And since a lot of the InfoSec tools, especially in offensive space that we use, like IDA Pro has IDA Python, and then these fuzzing frameworks like BooFuzz or the old Sully framework, and Scapy is Python. I mean, there's so much Python out there because it's such a friendly language, and it just made sense to do that. But I guess, Mark, if you want to give a little background about yourself so folks know who you are.
Yeah, my name is Mark Baggett. I'm one of the faculty fellows at SANS Institute and the author of a couple of different classes. 573, which is an introduction to Python for information security professionals. 673, which is advanced 573, and then SEC 406, which is an introduction to Linux for security professionals. And I've been teaching for SANS for 20 years now, I think. Started teaching out the mentor classes with 401, 504. And then you and I first met when I was teaching all things offensive. So I'm really, I'm offensive at heart. I still consider myself a hacker, even though in the coding world, hacking has a different world, but DEF CON, Black Hat, that's my jam. I love doing the offensive things. Taught 560 and other things. Considered teaching 660 for a while, but you seem to have that one covered at the time with people who are going on that. But GSE number 15. So I got my GSE a long time ago and one of the organizers of B-Sides Augusta, which is there we go. I got my my product placement in there on the class, so the other B-Sides organizers will be happy with that. But B-Sides is a pretty big information security conference. For as far as B-Sides go, it's we'll have about 1,000 people come together in Augusta, Georgia, which is my home.
How many of those are from Fort Eisenhower? Like the attendees, is a lot of them?
Yeah, so Fort Eisenhower, you've got an intelligence agency on Fort Eisenhower. You've got the Army's Cyber Protection Brigade. You've got Army's Cyber School, and Augusta, not being a big town, that draws in a lot of Then you think about all the support companies that need to support those organizations. It's a pretty small town, but it's not necessarily uncommon to walk through the shopping center here and see people wearing a black hat or a DEF CON or a SANS shirt, which is pretty cool. So I think that we probably have one of the higher per capita hacker populations of different towns out there. But so people coming who are associated with Fort Gordon, I'm going to say it's 40 to 50% of the people that are there.
I'm finally at the point now where I don't call it Fort Gordon anymore. It took me a year to finally stop doing that.
Yeah. Having lived here for 20 years, it'll probably take me a bit longer than you to adjust. It is in the DNA at this point. But yeah, so that's me.
Cool.
Yeah.
Yeah. So I asked Mark to come on just because I know he's got so many things to talk about. And I guess we named it Advanced Pickle Exploitation. I've kind of tweaked the title a little bit, as you probably saw, Mark, but against LLMs with Python, because it's kind of like Python was involved in this one, kind of, right?
Yeah.
Because PyTorch,
I saw it, I was like,
for some. Oh, sorry, go ahead.
I saw you change the title a little bit, and at first I was like, that's not exact, but it works because it's totally right. And the particular vulnerability we'll talk about and how to exploit it was used last year to compromise several hundred large language models. And while I won't specifically be exploiting a large language model, understanding this, you'll understand the principle of what happened with them and how those attacks worked.
And something Mark always does in his classes as well is, I didn't know he had this available, but he was like, oh, there's also a web page you guys are going to be able to go to if you want to actually perform and do the same things that he is showing today. So I guess during and after, if you want to practice the same thing Mark is going to show us, you'll have that opportunity, which is super cool.
Yeah. Yep. For sure.
Cool. So I guess, I don't know, do you want to give a little background on what Sleepy Pickle is and all that?
Well, yeah. So there's this Hugging Face, right? Is a series of a collection of different large language models that are out there, and Sleepy Pickle is an exploit that, at its core, it's Python Pickle, right? And if I see Python Pickle challenges in just about every CTF that's out there, right? But they're always the same thing. They're always a very basic pickle exploit, and the simplest of pickle exploits was actually very effective and used against the large language models in order to embed a backdoor into the large language models that were being distributed by Hugging Face. And we'll talk about that, but I want to go beyond that, because one of the things that I teach in 673 is how to exploit the simple ones, but we also talk about how you could mitigate those attacks and prevent remote code execution. So the remote code execution is something that can be fixed. The vulnerability itself can't be completely fixed, right? So there's still denial of service attacks and other things that can happen. And before I give out the URL, I'll just ask, please don't do denial of service attacks or the different variations against because to me, what it means is CPUs spike and Amazon credit cards get charged and things like that. So I'm kind of relying on people's good graces not to run up my credit card with CPU denial of service attacks on this thing.
Yeah, and all you'll do if you do that to Mark is make it go away for everybody else. So
yeah, I'll have to shut it down if the CPU spikes on these things.
Don't be that person.
Yeah. So please don't do the denial of service tax. So you can't, according to Python documentation, right? The vulnerability we're going to talk about cannot be fixed. And that's a true statement, right? You can't completely eliminate all of the vulnerabilities that there are around this thing, but you can mitigate the remote code execution. But even if you mitigate the remote code execution, there's still the possibility of tampering with the apps and having it do things that the developer wasn't expecting. If you know how to code up a Python object and pickle a Python object in a way that you can affect the applications on the back end. So we'll talk through some of that.
Cool. Nice.
Okay.
All right. Well, I guess as usual, I encourage everybody to go ahead and ask questions, of course, if you have them. If you've been on a stream before, you kind of know how it goes. We do a little bit of kind of chat in the beginning like we have. And then if anybody posts a question that's relevant, we'll talk about that. And then while the actual presentation portion, demonstration stuff is going on, unless the question is relevant to like exactly what's going on at that moment, we'll save those questions for the end, where we'll have another chance to do some Q&A. So again, encourage you to do so, but just know when and where we will get to them. All right. So I guess, Mark, if you just want to let me know when you want me to share the screen. And if you want to start just giving whatever background info and stuff you need, it'd be great.
Yeah, sure. Let's go ahead and share the screen, and I'll come up. So the website, and actually, let me come back over here to my other desktop. Let me come back over here to my other desktop. So the website for you guys to go to, if you want to go through and follow along with me, is serialization.crabdance.com:6730. And of course, 673 is my advanced Python class. So you'll have to at least type the nomenclature for my advanced Python class in order to get to this URL, right? So if you go, the first time you go there, you're going to see a YouTube video, and this only displays once. So if you ever wanted to go back and watch this video, you have to clear your cookies and go back here. But you don't need to watch that video because I'm going to walk you through and explain everything that that is on that video there. But if you refresh the page, you'll get to this. Okay, and this is a website that the website will accept a pickled object. Now, of course, this is just an easy interface into this website. Very typically, the pickled objects being passed as API keys back in between different communication channels, or you're usually going directly to some endpoint in the website that wasn't necessarily intended to be directly accessed on the website. So this is a bit of making it easy for you to exploit here. And this website, you can give it a pickled object, and it's got to be URL encoded. But you give it a URL encoded pickled object, and it will unpickle that object on the remote system. So let's talk about what pickling is, why pickling is, and what the vulnerability is here first. So it's not unusual in Python or in other languages that we might have variables that are stored in memory. So I'm going to come out here in Python. So if I said like x equals Mark, okay, some string, or in this case, that's a super simple variable, but more likely I might have objects that contain connections to website, maintaining connection to a database, or logging into remote APIs, or SSH connections, different types of more complex objects that I build in memory. And then I want to maybe transmit them from one Python instance to another. Like if you're going to do multiprocessing with Python, with multiprocessing, what it does is it spins up a Python interpreter on different processes. And then in order to transmit the variables between the different Python interpreters, it's got to get this variable out of memory here and get it into the other Python interpreter. So it'll serialize it, right? JSON JavaScript object notation is an example of serializing serializing variables. So if I wanted to serialize this object, what I could do is I could import the Pickle module, and then I could pickle.dump s, some variable, and then Pickle, you got to spell it right. And then it just creates a string, right? A serialized string, or in this case, a byte string of a representation of that variable. And then I could take that variable, I could store it in a database. I could transmit it across a network. I could, IPC it, inter-process communications between different Python processes to move it so other Python instances have these things. It's just a way of taking the variable itself, putting it into something that you can transmit or store, and then when you want to unpickle it, right? I'll just call this temp. And when you want to unpickle it, you pickle.load s and then load temp, and it'll give you back that, take that representation of the variable, put it back into a variable for you. So now you can begin processing it in your Python interpreter again, things like that. Now there's lots of ways that you can pickle things. There lots of different pickle modules out there. There's pickle, there's pickle dill. There's the dill module. There's the pickle jar. And there's a couple of other serialization modules that are available in Python, but all of them beneath the hood, they end up relying on Pickle in order to do that. And I say all of them. Of course, I'm incorrect when I say all of them. Like, obviously, you have like JSON. I can import the JSON module in Python and then export something to JSON, which doesn't rely on Pickle. But I'll say that most of the traditional serialization modules that you have in Python all rely on Pickle underneath. So going with one of those other modules usually doesn't fix the problem. JSON would, right? JSON is not going to, and JSON is actually a good solution to avoid pickling. And if you look through the Python documentation, it actually says, the best way to avoid these Pickle vulnerabilities is not to use Pickle. Or no, what it actually says is never load a serialized string from an untrusted source, right? So only load these from things that you trust. So that would mean I'd need to take that, and before I put it in the database, I would need to give it a digital signature, and then I'd need to verify the digital signature before I pull it out of the database, or transmit it across a network over a secure channel, things like that. So we never want to load a pickled object from any unsecured or untrusted locations. So that's the basics of serialization, right? It's a way to just take it, put it in a string, and then load it back up. Now, the problem, and this is the notorious problem that you have of Pickle, is that it has a capability that will give it, that a person can embed code that's going to execute when it's unpickled into the stream of data by creating a class with a method called reduce. Okay, so let me just show you a little bit of that. So if I was to create a new class here, and I'll just call it bad, all right, capital B, just so that the Python fanatics here won't judge me. We'll call it bad. And then if I create a function def reduce here, and this is going to take in self, what I can do is this has got to return back a tuple. And the tuple that it returns back has two things. The first thing is, I believe, the name of the function you want to call. And the second one is the arguments that you want to pass to that function. So I'm going to say os.system is the name of the function that I want to call. And then I want to pass it the arguments. Now, the arguments always, you have to put a tuple here of multiple arguments. So if I just wanted to pass one argument, like I wanted to run the ls command, right? Even though the ls command is the only argument I'm going to pass, I've still got to put it in a tuple, which means I'm going to put an open parentheses, close parentheses, a comma there as that second argument. Okay. All right. And so if I create this object called bad, and then I, let's create an instance of a bad object. And then I pickle.dump pickle.dump sx, right? Then that doesn't contain the word system. I did something wrong there on that. Let me look real quick. Let me cheat and look at my code here. I did something wrong on the, I guess I could go back to the website here. Oh, it's done to reduce, def. Done to reduce. There we go. So let's try that again. Okay. And we'll define those objects, and then I'll create an instance of it, and then we'll dump it. You notice at this time, it gave me an error message that said, hey, there is no OS module. It's just because on my system here, I haven't imported OS yet, so it can't grab the necessary objects in order to build that. So I'm going to import OS, and then I'll create my instance and dump it again. All right, and so this object here, if I was to then take that to another system and deserialize it, and actually, rather than taking it to another system, what I'm going to do is I'm just going to open up another Python interpreter here. So I'll come over here. I'll just say Python. And then I'm going to import pickle, and I'll pickle.loads those bytes. You can see that my ls command ran, right? So that reduce function that was attached in there and is embedded inside of this byte string, you can see system here and ls here. The name of the function you're going to call and the module that it's in is embedded within the byte string for the reduce function. Okay. Now you'll notice that in this module here, I hadn't imported OS directly, but OS actually was imported because when you import Pickle, it imported OS. And just about every module that's out there is going to have an OS module that, or every Python framework, the Flask object out there is going to have OS already preloaded on there. So this os.system with ls or ID, that's the most typical kind of a thing that you're going to see in CTFs is here's a thing you can do and embed code. So now I can come back over and put any command I wanted to. Right here is the argument that's being passed to, OS system and the function that I want to pass to it. Okay. Now we'll teach you how to mitigate this in 673, and we'll talk through it a little bit here in a moment. But let's kind of explore this a little bit more. And actually, let's take this. And if you're following along and you want to try this on the website, I do have to take that byte string and then and URL encode it in order for me to put it on the web page. So I'm going to import here. Let me clear my screen so it's up at the top. Import urllib.parse. And then I'm going to call urllib.parse.quote and then pickle.dump sx. So I'm going to dump it again and then urllib encode it. So now if I take this byte string here and I put it back into my website over here, then this is going to be transmitted to the website. The website will receive this byte string. It'll deserialize it, and that code is going to execute on my web page. And that would have worked, right? And that actually would have worked against those large language models and things like that. That very simple exploit of just attaching a reduce function worked. But it doesn't work here because I've mitigated it. I've taken some of the steps that we talked through in 673, and I can pull up those slides in 673 and show you how we walk through mitigating that here if we have time to go through that when we do this. But what I want to talk about here is even if the remote code execution has been mitigated, right? But as I mentioned, there's still denial of service attacks and things like that are there. But if the remote code execution has been mitigated, they're still not out of the woods, because I'm still creating an object that gets transmitted to the remote system. And then the remote system is deserializing that object into memory. And there's still a running program that's depending upon that object and going to use that object to do something on that remote system. And well, I get to control attributes and things like that of that object, which can allow me to control different aspects of the application. So just to give an example of this, that what this web page does, and it tells us here that it says that in this particular web page, that the object that it's receiving, is called a custom socket object. So it's expecting to see a custom socket object. And then within that custom socket object, it eventually gets to the point where it recalls this method that is attached to that custom socket object. And here you can see that it calls a send message, right? And in that send message, it does a self.send to, right? We will, in 573, the introduction to Python, into information security Python, we talk about how to develop command and control backdoors in Python using TCP, UDP-based objects, and how basic TCP communications over Berkeley sockets work at a programming level. And send to is a method that is inherent to all UDP objects. So this is being inherited from my parent class. So it's going to call the UDPs send to, and it's going to send a self.message, and it's going to send it to self.ip to port 673. So that means that if I can create a serialized object that is of type custom socket, that has a message attribute and an IP attribute, I can control those attributes in the data that I'm sending it up. And so your goal in working through this exercise is to create a serialized object that is a custom socket with these two attributes, and then embed that in there. And then it's going to, the normal program execution on the back end is going to run through, but rather than sending the IP address or the message to the intended IP address, or the one that was originally object or in the programming space, it's going to, well, you can change that self.ip address. There is a message that was originally on the object that you're deserializing in that code, and there's an IP address. And you're, by serializing this object, you're in essence creating a new instance of a custom object that is going to be used so you can control the IP address that the message is going to be sent to. And so that's kind of the goal of this CTF here. Okay. Do you have questions so far, or you get
in most CTFs? Is it typically just like, oh, run a LS and then see the flag file and then cat the flag file out?
That's typically what you'd see in like Pickle CTF and other things. You just use reduce OS system, run an LS, you'll see a flag. In some cases, it might ask you to. I mean, hey, this is remote code execution with reduce, right? You can put whatever commands you want in there and look at things. Sometimes it'll be, create a file on the hard drive, or read a file, read a copy of Etsy password. So certainly OS system, I could in my object back over here, when I'm creating this could be cat as the first option, and Etsy password is the second option, and or Etsy shadow if their web server is running as root, which still happens these days, despite what a bad idea that is. So with OS system, you can put arbitrary code of your choice, and it would be rather than putting all of the commands inside of one quotes, every independent command is going to be passed as a comma separated list of values that you have in here.
And the reduce function's just like giving the instructions on how to serialize or pickle the object, right?
Or to unserialize it. Yeah. So the original intention is if I wanted to pass in an object that I wanted to have, when it deserializes it, I want it to have a default state, default set of values. I could, this might be something like list would be the first argument. And then this would be the list of values that you would pass to list to have it pre-populate those items with it. So that's kind of the thinking as to why they put this in here. Now, reduce is really the only function that has this remote code capability. Although as I'll show you as we dig into actually exploiting this advanced version. But
got one question here. I just posted it. Could a command be implemented in Linux that scans the contents of the pickle and then ls the bytes without actually running it?
Could a Python object be created that goes into the Python interpreter's memory and finds ls and executes it without executing ls? Let me hold that question off until we dig into some of the deeper parts of it, because as you're going to see, what you can do here is limited by the object that is defined on the exploited target. Okay, so I really can't do much more than just this when it comes to code execution. I can give it a function, an object. System is a function, OS is a module. I can give it a module and a function, and then arguments that I'm going to pass to it. But this object and this function has to already exist on the remote system that we're uploading the code to. As it happens, every Python module imports OS. So this is a reliable set of things that I could do almost always. But those things do have to exist already in the remote system.
So we'll do one more real quick from Victoria. Are there any other serialization modules aside of Pickle where this may apply?
Yeah, so dill, I know it affects dill. I know that when, Hugging Face, the Sleepy Pickle vulnerability, I know that when you're using PyTorch and you create PyTorch machines, that those are relying on Pickle on the back end. When you're doing multi-processing and you want to send objects between processors, that's relying on Pickle. It's on there. Only one I know of that doesn't is JSON, right? You can import JSON and dump it, but everything else that I've used on Python ultimately relies on Pickle on the back end and would be vulnerable to this.
Cool, thanks.
Yeah. All right, so let's dig into this a little bit more for this advanced object. So one of the things that's important to understand about Pickle and what goes into this byte string here is that the only thing that's really there is instance attributes. Okay, so like when I create a class off by one is going to be an object, and I'm going to give it a class attribute, right? A class attribute of host equals Steven Sims. Okay, and I'm going to give it a. What's that?
I was joking. I said, "Don't dox me, bro."
And I'm going to give it a new function. I'm going to attach a method to it called when, and it's going to take in self, and it's going to return Fridays. Is that right? You're on always Fridays?
Yeah.
All right. So we got a custom object here of Steven Sims. Now, if I create or off by one, if I create an instance of an off by one and I dump it, pickle dot dump s x, and I'll put this in. I'll just dump it. Okay. Then I take this byte string. And we'll go over to another Python instance here. And over here, I pickle.loads this byte string. And let's put that into control A. Let's press enter. Notice here that in this Python instance, it says, hey, class can't get attribute off by one because this Pickle or this Python instance doesn't have any concept of what an off by one module or object is. So you can't serialize objects that don't exist into on the remote system. Now I could just create a simple class off by one here and pass, right? It doesn't do anything. So now at least this instance understands that, oh, there is this object called an off by one, even though this definition is very different than what we created back over here, right? Here, this actually had something attached to it. Here I'm just saying pass, which means do nothing. This instance is different, but now at least, right, it doesn't give me an error message. It does give me back an object. And if I put that object into a variable and Control E, close parentheses, and I do a dir on x, x dot host isn't there. X dot when it isn't there, right? So those class attributes and those class methods have to be defined on both the instance that created the serialization and, or I guess technically it doesn't have to be defined on both, but if it isn't defined on the thing that's deserializing it, then it isn't going to exist in the object that's there, right? So it's not like you can just arbitrarily create methods, serialize them, and then have it magically appear inside of the target system. That doesn't happen. But what does happen is instance attributes and instance methods. So if back over here, if I take my X instance and I was to just start creating new attributes that are attached to it, like here's an X dot guest, which is equal to Mark. Okay. If I then add an attribute to that instance, right? Notice I didn't add it to a class. So an off by one object has a host, but it doesn't have a guest, right? Because it's not defined on the object itself. That attribute actually only exists on the instance. Well, if I now dump that, pickle.dump it, and there you can already see that Mark and guest are in that serialized stream. So if I take that and I come back over here and I deserialize it, pickle dot load s, that, close parentheses, and let's just put this in variable x. Then my variable x has a dot guest, doesn't have a dot host or any of the other things. So it's just those instance attributes that get transferred over to the other instance, which in a scenario like we have here is actually really convenient for me, because that means as an attacker, I don't have to reverse engineer all of the stuff about the object that's running on a remote system that I may or may not have any visibility into. Right? If I got zero visibility into this thing, then all these attacks are going to be hard, because in that case, I would even be trying to guess that this thing has a message ID and a message attribute and an IP attribute. But if it's an open source project, if you have some suspicions that they are relying on core Python objects like a UDP socket or things like that, if you have knowledge about the core modules that their applications are likely relying on, you can, well, manipulate those attributes. And in many cases, the methods, which you can attach methods to instances as well, which I'd have to pull out some 673 slides in order to do that, because I don't remember it off the top of my head. So what can we do here? Well, that means that all I have to, in this case, is create a message attribute and an IP attribute attached to an instance, and those things are going to get embedded in my serialization bit. So let's do that here. Let's hear it. Well, I'm going to have another problem here right now, and that's because my class is called off by one. So in the serialization process, we saw that when I tried to deserialize this here, and it didn't yet know what a Oh, and I hadn't imported the OS module, or it didn't have any reference to what an off, there wasn't an off by one definition in the target. It gave me back an error message, right? So it does try to instantiate an object of a specific kind. And I know here that this website says I need this to be a custom socket object. So in order to exploit this thing, I'm going to have to create something called a custom socket object, because that is the type of object that it's going to be creating on the remote system. So let's create a class called custom object. And it's just going to be based upon a plain old object, which if you're a Python 2 coder, right, for the longest time, you would just define these as this. Python 3, the best practice is to say it's based upon an object, but those two functionally, they do the same thing in Python 3. Okay, so here I'm going to create a custom object, and I'm not going to do anything to it. I'm just going to say it's custom object. Now it tells me that it's based upon a UDP object, which I could make my custom object inherit a UDP mod, or the socket UDP module, but that's not necessary here. But all I'm going to do is create an instance of a custom object here. And then I'm just going to add those attributes, those instance attributes that I want to override or manipulate on the target system here. I'm going to say x.ip equals. Now, if you're doing this remotely with the website, you would want to set this to your IP address. Okay. So yes, you are giving me your IP address on that website. So that means I'll know who you are when you deny a service. No, I won't. I feel pretty confident your audience can get around that. 127.0.0.1. I'm just going to do this since I'm doing this on my computer so that when you guys crash my server, this demo still works. I'm going to set it to 127.0.0.1, and I'm going to create an x.message, which is going to be just hello. Okay. So now I've got an instance of an X object that I can pickle.dump s. Okay. And I can also, oops, that's not what I wanted to do. Let's make that bigger so we can read it. All right. And I can pickle.dump s. And I can URL lib.parse.quote to turn it into a byte string. Okay. So now I can take this stream of bytes, copy, and we'll go back over here to my demo page. I'll do this demo on my system. Actually, before I can do this, I'm going to have to exploit this with the let's refresh it. And I'm gonna have to exploit it with the simple one first. So let's just grab, I think, this set of let's see. All right, let me go back here. I got to get past the level 1 before I can show you level 2. So let's just say y is equal to an off by 1 and pickle.dump s y and URL lib.parse.quote dump that parse. That's one thing about my 573 class and 673, I'll say, is if you take them on demand, I don't edit out my mistakes in there, because I think that it's important to see how I troubleshoot those when I make those mistakes. All right, so hopefully that would have worked. Excellent. So now I'm on to the second stage here. So now I can go back over here and let's take that new one, the one that I defined here. All right, so here we did a URL parse.quote, and we dumped the one where I created an instance. Remember, we created an instance of, no, it's not. Oh, that's going to be wrong. It's not called custom object, is it? I think in the website, it tells me that this thing was a custom socket. All right, so let me do that again. Class needs to be a custom socket. It's going to be based upon an object. and we'll do nothing to it. And then I'm going to add a IP address. Oops, let's create an instance of an X first. And then we'll add an IP address to it. We'll add a message to it. And then we will dump it. So now if I take this and I put that in my website, it's going to send something to me in an IP address. So I'm going to need a listener. It does tell us in the instructions that it sends us to us over a UDP port, and it says it's sending it to port 673. Okay, so that's on the web page there, on that nicely done web page. So I'm going to set up a Netcat listener listening on UDP, listening on port 6730. You can see I'm listening on port 6730. We'll come back over here to our web page, and we'll put our byte string in here. And it says message sent. We come back over here and we get that flag. Okay. So even though the code has been restricted and controlled in such a way that you cannot do remote code execution, we still have control over attributes on objects that are running in memory on that remote system. And we can still manipulate those to have it do things that, well, we want it to do. Now, doing that is going to depend on you understanding objects that would be in memory and what the capabilities of those objects are, and then going in and setting your attributes or appending methods to things, overriding methods that are in things. So while you can't embed class methods, you can embed instance methods, and those instance methods will overwrite class methods that are defined on the remote systems. So you can do this also for code, right? And having instance methods defined inside of your objects that you serialize and transmit. Okay. And that's basically how we can do that advanced exploitation. Other things we could talk about, if I'll take questions, and then other things we could talk about is we could look at how the mitigations work in this thing, if you'd like to see some of that. But that's what I have for you, Steve. I hope that's useful.
Cool. Awesome. Yeah, that's super cool stuff. So thank you very much for coming out, and again for setting up that web server for folks. I think that's really cool and helpful when folks get a chance to try it out themselves. Yeah. So for folks online watching, if you have any questions for Mark, please go ahead and post them up. This would be the time to do it. I'm going back through some of this stuff. I was just trying to answer a question from Candy asking tips on areas to learn advanced obfuscation, reverse engineering, polymorphism, living off the land, and kernel level rootkits. I don't know if you have any thoughts on that while we're waiting for questions.
Kernel level rootkits.
Yeah, I posted obviously Jonathan Ryder's intro to C, but it sounds like they've got C experience. So I posted a couple articles. There's one short course that you saw I posted up there it's called Building C2 Implants in C++, a primer. It's a really great kind of introduction to get started in that space. I don't know trying to think, and folks online, if you have answers to that as well, questions and your thoughts around learning obfuscation tricks and kernel implants. I mean, most of the stuff that I know are courses out there that run either at Black Hat or SANS or other places, which I know that a lot of times people are looking for something a little more affordable. Garen's asking, how do we mitigate this as a systems administrator?
Yeah, I'll talk a little bit about that here. But hey, let me ask you a question. And this is, I have spent the last several years teaching my Python class, things like this. But as I've said in the intro, I'm an offensive guy by heart and cut my teeth in the offensive side of information security. My answer to that And I want to give my answer to that, knowing that this is going to show my age and get your response to it. Rootkits.com, right? Or the book Rootkits, right? To me, even if some of those techniques have been mitigated by operating system fundamentals and things like that, the core concepts that are taught in those books are going to be invaluable, in my opinion, on developing those things. Now, I say that knowing that I have no idea what I'm talking about, and that I haven't looked at it in 5-6 years, and things change rapidly. So what are your thoughts on what I just said there for that answer?
It's funny because just recently I was having a similar conversation with some folks online who were like, some people were slamming Hacking the Art of Exploitation, and other people were saying, no, it's still a great book. It is still a great book. It still has, like, anybody who wants to learn exploitation or rootkit dev or whatever, those foundations, like, you can't just jump straight into, I want to bypass HVCI and get kernel code execution on a Windows 11 box. And you've got to learn all the foundations, the basic buffer overflows up through use after free exploitation, type confusion. Just recently we had Alexander Basholi on. We're talking about a vulnerability in V8. It was a type confusion bug in Chrome V8. Super cool stuff. So kind of working your way up, and also the theory and methodology behind it is all absolutely valuable. As you said, the mitigations and stuff factor in, but the only way to learn how to get around the mitigations is to understand how those mitigations are actually breaking your attack technique.
Yeah. And I mean, DLL sideloading has been around for forever, right? And I think that when we'll talk about user level rootkits and things like that. I think that is still pretty state of the art stuff, isn't it?
I mean, sideloading still definitely, especially if it's a third party DLL signed, so it'll load. Then obviously for like the long game, for long term nation state campaigns and such, I mean, you never know if you stick that DLL somewhere, get it out there, when someone actually ends up loading it. So you could have a listener up, and then all of a sudden 6 months later, a shell pops up on your screen. You're like, whoa. So absolutely.
Right. Yeah.
Any,
so I don't know if you've got me on screen or my screen.
is your screen still up? Yeah.
My screen's still up. Okay. So you were about to. I've got the code here that is restricting the unpickler to answer the question about how do you address this as a system.
Right before that though, Jonathan, who's still on, had a great question, which is, hey Mark, would you ever do a stream on making custom Python C2 frameworks?
Yeah, that could be a fun fun YouTube series that's on here. I don't know that would be a 3-hour podcast or things like that, or just a stream session. Right. To answer Jonathan's question, anything for you, buddy. Right. Yeah, I mean, I think I would want to break that down into a YouTube series of different things, because there's so much. Because I mean, the way that I would approach that is I would build a Flask module, right, and have that Flask module be up and running all the time for sending comms back and forth on those systems, and then I would have a Python implant. Sorry, Jonathan, on that remote system. So we'd have to talk about web communications in a Python client, building a Flask framework and things like that. But to build that is actually pretty simple to walk through those things once you understand the concepts in Python. And you could use a C implant if you wanted to, Jonathan, to talk to that web framework.
Cool. All right. Well, yeah, let's show the mitigation.
Yeah. So by default, when you unserialize a Python object, it just unpickles it. But you have the ability to create what's called a restricted unpickler. Okay. And here you can see on my screen, I've got a restricted unpickler. So I'm saying from the pickled object, or from the pickled module, let's import an unpickler. Unpickler is the kind of object that does the unpickling. And then I'm going to inherit all the capabilities that come with the core unpickler that's built into Python. And then I'm replacing the find class method that is on the original object with this new version of a find class object. And what this version of the find class method, its job is, hey, if when we're taking that stream of bytes and trying to turn it into an object in memory, if it uses any functions or modules or objects that exist in memory, its job is to go off into memory in the Python framework or Python process that's running and define the definitions of those objects so that it can then instantiate those things locally on the system. And so here I'm replacing the original find class, which in an unrestricted way just goes off and takes whatever objects you tell it to grab from memory and build them, with this module, which looks at, now you'll notice that the reduce module, we pass it in 2 arguments, right? We pass it in os.system, which is the module that it's calling, and we pass it in arguments, and it would pass the arguments to that module. Well, here we can see those things manifested in this find class. Find class takes in the name of the module that defines the object it's trying to create and the name of the instance that it's going to create. And so what I'm doing here is I'm looking to say, hey, is the tuple that's made up of the name and the module in this list of allowed objects? So in this case, I'm only allowing you to instantiate these types of objects in memory. I'm going to allow you to create a custom socket, which is the kind of object that's defined in the main program. I'm going to allow you to create an AF inet socket, which is, well, a UDP-based socket, right? And a sock.dgram. This is the underlying module that a UDP socket is made from, or a sock.dgram socket, which is a UDP-based socket. And those are really the only types of attributes that this thing will go off into memory and find the instance for. And for all others, it's going to raise a hack attempt, right? So if it's not one of those things that's in the allow lists, notice we're using allow lists and not deny lists. And in 673, we get into very practical examples of why you must use allow lists and not deny lists. Just a very simple example, os.system, when it reaches this module, this function, it's not os.system, right? Os.system is a generic interface that Python changes into operating specific versions of modules. So for example, if I'm on a Linux system, when I call os.system in my Python program on a Linux system, it relies on os.posix. On a Windows systems, it's os.nt in order to actually do the code execution. And so you've got to, if I was to just say block os.system, it wouldn't have done anything because, well, os.system isn't os system by the time it reaches this object. So we're going to do allow lists, right? We're going to say only allow these types of objects to be instantiated. If it's not one of those objects, raise a hack attempt. And for everything else, all other objects, well, then I'm going to call the original. We're going to use super to call my parent objects, the original find class module that was on my object, and pass in the names of the modules that I want to, the module that I want to pass and the name of the object. Let it instantiate that object. Okay, so here's my restricted unpickler. You'll see that down here in my code for this, let's see here. We use a restricted unpickler in here when we unpick it. Let's see if I can control F, look for restricted. Oh, there it is. Okay. After I unquote your bytes coming off that web page, I use my restricted unpickler to create that socket object. Okay. And then now I've got this. If I had just done a straight old unpickle, right? Pickle.loads here, I could have done a pickle.loads, and then it would be vulnerable to those code execution. So the answer is, how do you fix this as a systems administrator? My question is, are you a systems administrator that knows how to code in Python? or not? Okay, because the answer is you don't. If if you're a systems administrator that doesn't know how to code in Python, okay,
Makes sense.
you have to rely on people to have been writing modules that are not vulnerable.
Makes sense. Cool. Some more questions. What are your thoughts on I don't. This might be out of context, but what are your thoughts on a ChatGPT model for security?
Well, I think that we're getting some of those, right? I think Microsoft has that, and certainly different frameworks are trying to build, Chat GPT or large language models that are trained exclusively on information security documents and principles and things like that to try and uh, uh, leverage AI in order to implement some things for network defenders and offensive folks. Steve? How successful have you been in? And we can take my stuff off the screen now if you'd like, unless there's something else we can pull it back up here. But how successful have you been in using like ChatGPT in order to develop exploit code? I often find that ChatGPT will get to a point where it's like, hey, I don't really like what you're trying to do here, and shut down when it comes to any type of
It's interesting. I did a talk at Hackers Teaching Hackers back in November on that topic. At least it was part of the conversation. And also, like ChatGPT and with OpenAI, they obviously like prompt injections and escapes and things you're trying to do. Like they're always patching that stuff. Every time somebody finds one, they're patching it, they're making it better. Like obviously the first ChatGPT version that came out, you could say, hey, write me ransomware in C# and it would just do it. And then obviously they put protections in, and then you got to trick it. We've all done this before. It's nothing new. But one little trick is if you get an academic license to ChatGPT through OpenAI, you can actually have state, meaning that you can have a instance that does not get patched, and it won't ever get patched unless they change their policy. So any of those safeguards and things that they continue to put on in the public version, if you have the academic license and can have like statefulness, you can get around a lot of that and not have to worry as much. But obviously, a lot of people, I've always said this as well, which is nothing novel, that there are certainly people out there who have unfettered access to these models, right? That they don't have the protections. I'm sure people at OpenAI can turn them off and they can ask it anything. So those with that level of access have a super high advantage against everyone else. So it's pushed a lot of people, obviously, to creating custom models. On the vulnerability research side, I started a project which was with somebody here in Berkeley at UC Berkeley, who's a lot smarter than I am on the mathematics part. And the idea originally was exploit development. And I saw Google, I talked about this before as well with their deep sleep, and it was called something else prior to that. But that is their research product. I think they got about 20 people on a team under Project Zero focusing on using LLMs to find and write exploits. And they posted a lot of really great statistics. And at first they were saying it's going to be a long time before this replaces security researchers because there's so much nuance in everything that a model can't do. And then they came out with Deep Sleep, their continuation of the initial project, and they were a lot more optimistic. I think back in October, they found their first vulnerability using AI. It was something in, I think, SQLite. I think it was SQLite, something like that. And it was, I can't remember the type of bug it was, but it actually discovered and weaponized, and it was responsible. And they claimed that it was the first example publicly anyway of AI finding a vulnerability that was then reported and got a CVE and a patch. So that's pretty promising. Obviously, the web exploitation side of things, I've heard this as well from a lot of people out there in the web bug bounty world, like HackerOne and BugCrowd. The top 10% of the people who are making the most money, they've got some really cool tricks as to how they are able to discover things quickly. And it's always been a trick where you monitor these websites that have good bug bounty programs. And it's almost like you're using the tripwire technique where you look hashing and hashing and hashing and checking for any change to the website, because that changed. Obviously, now there's a potentially new attack surface there. So they always kind of target their focus there. And they've been complaining about people who have been utilizing AI to then scan and assess and perform at a much faster level. And so some of the folks that were winning a lot of those bounties have been kind of like dropping down because of the people who are using AI. But back to the original question, my experience with my goal originally was to come up with a model that is able to weaponize patched vulnerabilities. So basically, when Patch Tuesday comes out, you can go out to one of the sites that give you the patches, or you can extract them yourself, and then feed into the model both the unpatched and patched version in a decompiled format of the functions that are involved in a vulnerability. I've done a ton of patch diffing stuff on here before, so you know how that works probably.
Yeah.
So you might have 20,000 function DLL, and only one or two of the functions inside of code changes when you do the diff. So you take the decompiled versions of those, you feed it to the model, and it's you're hoping that it would say, oh, here's where the vulnerability is, and here's how you could potentially exploit it. Exploitation, though, was later on my list. The initial focus has been on getting it to work at being successful in identifying the proper bug in the code. Because what, like you asked, if you go and take decompiled code and you give it to ChatGPT and you say, hey, what are the vulnerabilities in this? Are there any vulnerabilities in this? It's all BS. It's all false positives. Like almost always, it's garbage. And I sit there and I fight with the thing. And I'm like, no, that's wrong. You can see right here that that is not a logic error because of the arithmetic at this location. And it's always like, oh, you're right. I'm sorry. And then it prompts you and says, how would you prefer that for the next person asking the question you asked, I respond to them? So you're basically teaching the model, which is fine, but that's not your job. And you don't feel like that you're not getting what you want out of it. So its ability to take code that where there's a complex vulnerability in it and identify the right thing, it's bad at it. The more context you give it around the details that Microsoft gives you in a CVE report or the knowledge base article, obviously you can hone in on things, but it's teamwork between your experience and knowledge in exploit development and its capabilities of having massive code base in its stored. What ended up happening for the project I'm working on is it ended up not being so great, because I thought that if we fed it every Microsoft patch and associated vulnerability details throughout the years, that it would then better understand how Microsoft patches code, and that it would quickly be able to identify the likely vulnerability and point you in the right direction. And then that way, at least you can then go and start trying to trigger that line of code and test it. But what ended up happening is it's still not great at that. But what it is really good at is if you give it a code base, now that we've trained the model in understanding so many Microsoft vulnerabilities over the decades, it's seen so much Microsoft code and it sees how they fix the code. It's better at identifying 0 days. We've already discovered 2 using it. I know it's not a lot, but it's still something where I give it a code base. Like I'll be thoughtful about what I give it. Like I'll look for deobfuscation, decompression, decryption, any routine that's related to memcopy calls and stuff like that, where something might be interesting. So you've got to identify an attack surface that makes sense for you, and you have to know what you're looking for. But you give it the code base now, and what it's been good at is it says, I've seen this code before. And it references a CVE, like on the one we found from 13 years ago. It said this code was seen in this code 13 years ago, and that's how they patched it. So it is identifying the unpatched version that we fed it in prior patches, and saying, hey, this could be a potential vulnerability because that code block looks exactly like the code block I saw in 2011 or whatever. I know it was a long-winded answer, but hopefully it answers the question.
Yeah. I mean, one of the things that I loved most about 660 was the IDAPRO and comparing the bin diffs between 2 different DLLs and actually being able to follow the paths and seeing where functions diverged and where to narrow down the code block changes. But that was a heavy process, right? So even if AI can shortcut that
Yeah.
and make that so much better, I once heard someone say that AI is not going to replace anybody, but what's going to happen is people that use AI are going to replace people that don't use
Oh
AI.
yeah, exactly. Exactly.
And I think that that's pretty true. It, I'm this is just another baseless hypothesis that I want to get your thoughts on. Um, are you finding that your AI model is better at finding memory corruption vulnerabilities than, say, race conditions or well, ultimately, I guess serialization bugs often are the result of often result in memory corruption. Um, but but I just have a suspicion that after we've finished all of the memory corruption bugs that are out there, that we're still going to be left with a ton of race conditions,
Oh yeah.
just because threading is so hard, and to do it right, even if you do it right, you're still going to run into problems like the dining philosopher problem and all those other things that I suspect that when we're done with all the memory corruptions, we'll still be faced with years of rich bug hunting for race conditions. But I think those are harder to find. Um, do you think AI has a place there? Somehow this has turned into me interviewing you. I'm not quite sure how, but do you think that there's a
Yeah, I mean,
uh,
double fetch vulnerabilities like TOC, TOU bugs. I mean, they got pretty hot like 10, 15 years ago when Google Project Zero discovered a new way to kind of catch somebody. I think they disclosed to Microsoft like 70 double fetch bugs. I was at SciScan in Singapore when they disclosed that. It was an amazing talk. And that got me interested in that a bit, kind of like, and I've seen Microsoft kind of mitigate some of that by trying to reduce the attack surface by like introducing mitigations like disable Win32K syscalls. So you've got like the NT syscall table, Win32K syscall table, where if you enforce that mitigation, which reduces the attack surface to the kernel greatly. It's over 1,000 functions that are now not exposed into the kernel because you've turned that mitigation on. But the mitigation can't be turned on if you're using GUI threads. But you can, if you're a developer that understands how the mitigation works, which is part of the problem. Some of the mitigations, the more modern ones coming out, require that the developer writing the code understand the mitigation itself, how it works, and how to call it and use it. So that's why Microsoft's really good at using it, but then the third-party app developers aren't. But yeah, absolutely. I mean, logic bugs are really hot right now because memory corruption is so hard to exploit with the mitigations out there. I don't think we'll ever be done with mitigations. I mean, the with memory corruption bugs, but the challenge is actually being able to weaponize something and get around the mitigation. So even though the vulnerabilities are there, you can't exploit them. But certainly, like I focused primarily on memory corruption bugs with this model, and that was really the goal, was to find those types of things. But the other vulnerability we found was unsafe DLL load one, which is a pretty simple concept. I wrote an IDA Python script actually that tries to find it programmatically by using IDA and just scanning for. It was such a simple concept, which sometimes that's all it needs to be. Like I wrote a IDA Python module years ago that was looking for use after free vulnerabilities, and it specifically looked for uh, classes, C++ classes, and functions that have an add ref but not a release, or a release but not an add ref. And I got a lot of false positives, but actually, the way Microsoft implemented smart pointers with the invasive method left it open to vulnerability. I asked David Weston at Hackfest back in October, like, why did Microsoft choose to use the invasive method for smart pointer implementation? And I've always wondered that, because the way that there's three ways you can manage a reference tracking on C++, and with smart pointers, and they chose the one that is vulnerable by having the reference counter and the v pointer inside the instantiated object. And so looking for functions that are messing with the reference counter but aren't properly incrementing it in the first place was one way I found it. But the unsafe DLL load situation was another really simple concept, which was the way that those work. And I remember I got into that because Laughing Manus, Greg Linares, found a vulnerability and Microsoft patched it. And he told me that they patched this bug, and I wanted to go find it and weaponize it. And this was a really interesting one because it was on Windows 10, and it there was the thing that made it vulnerable is that the DLL that was trying to be loaded by Skype, by Edge, by a couple other applications didn't exist on the file system. It was called phoneinfo.dll. It wasn't there. Like they forgot to include it or something. So the way that unsafe DLL loads can be exploited is one, the DLL has to not be on the system, or you need to be able to get your malicious instance of that DLL in a load location that's higher up on the priority list. Because the way the load order works on DLL loads is it starts with the current directory, and then it goes to system 32, and then it goes to system, and then it goes a couple other places, and eventually it goes down to the current directory, which no one knows what that is. It could be a UNC file path. And then it goes into anything in the environment variable list. So like when you install Python on a system for any user and it puts like on the C drive, the way it used to happen, especially world writable, world readable, you could load that DLL in there and you could exploit the target system that way. The other thing that's required to make it vulnerable, though, is that the argument for the DW flags has to be set to 0. Because if it's 800, then it's protected and can only be loaded from system 32. If it's 0, then it can go follow that search order list. So if the DLL is not there, or if you can get it higher up in a priority list, you can exploit that. So, I think that absolutely AI is going to have a place for all types of bugs and finding them. I tried to learn a lot from like Sandbox Escaper and the way that she was very generous in sharing the ways in which she found these logic bugs. And she was always saying, oh, it's so easy. Like, I don't think people realize how easy this is. And once you kind of figure out how those logic bugs work and how you can find them, they're all over the place. And I think AI will certainly help with that as well. Someone was asking you a question on, are there any good resources for LLM research, LLM exploitation using Python? Do you know of anything for that?
Well, I think it's a really broad question. I mean, every Python module or every AI implementation out there is largely Python based, right? I mean, matplotlib, scilern, and everything is being developed in Python. So I'm not quite sure where to go with that question. There's so many different ways that if you understand Python that you can manipulate Python. I'm guessing that you mean within the large language models. And I think that a lot of those things come down to it's not necessarily the Python part that's hard. It's the understanding how to just attack large language models in general. Like you were just going through all of the memory corruption and DLLs and things like that. And I was thinking, oh, you know what? I should really plug here that in 673, we talk about the C types module and things like that. But the thing is, in Python, understanding the C types module and loading up a DLL and calling it is a 5-minute discussion, right? And the real power there is understanding all of the Windows libraries and what to call and what data structures to build and things, and all the things that Jonathan teaches in his class is really, I think so. It's really exploiting those things on Windows. You could do it in Python, but it's really Python is just a wrapper to the underlying C code that's being exploited. And I think this probably the same could be said for exploiting large language models and things like that. Although with all of those things, when the development of the exploit is going to be done in, exploiting the Windows APIs or exploiting the large language model through some cute prompt. But ultimately, when you write a tool that distributes your exploit, you're probably going to do it in Python because that's what everybody's going to run. But along the lines of DLL side loading and path hijacking and things like that, Python suffers from the same thing. Within the Python of when you import a Python module, it still goes through current working directory, and the directory in which the Python script that you're running is loaded as first, and then current working directory, and then starts going through the systems. And you still have the opportunity to put malicious modules in there with Python as well, in the same way that you can with C. Am I going to join the Obi-Wan Discord server now? Jonathan, I've never been invited to the Obi-Wan Discord server until this chat message right now. So
we post it all the time in the videos and stuff. It's open to anyone. It's got about 2,000 members right now. It's a pretty good group of people.
Okay,
but you're welcome to join.
I should definitely join. Since
Cool.
Jonathan called me out publicly, I will join.
Go, I was responding to somebody real quick. Yeah, I just posted a response to somebody who asked a question, but I'll say it verbally as well because it's important. In my experience, both with using ChatGPT or even the custom model I'm working on, you can't just take, you're not going to have much success. Like imagine if it was a buffer overflow vulnerability, like a classic old school stir copy with no size argument, and you can copy however much data into the destination buffer and overwrite things. Like if it's that type of bug, it'll find it instantly. Like basic capture the flag challenge is really good at that stuff. But for difficult bugs like type confusion, use after free, or anything in that space, if you give it the function that actually contains the root cause of the vulnerability, it typically still won't be able to find it. Like you can say, hey, there's a bug in this code. I think it's use after free or type confusion or something else, or sign extension bug, whatever. Can you find it? Usually it won't find it. This is where the context comes in, where the disclosure information that Microsoft or whatever vendor it is gives you a lot of times are the hints you need to be able to find it yourself or get AI to help find it for you. It needs context. It might be cross references to functions that vulnerable function is calling, or functions that call it. Oftentimes these are virtual functions and you're working with indirect calls. So it's not always as easy as that. And usually it's not. So if it's an indirect call, then you have to understand, like, oh, is this an RPC bug? What type of vulnerability is this? And then your familiarity with that particular technology will be very important. And also your knowledge about exploitation in general becomes important. And that's why we say things like, it's not going to replace us anytime soon, because it needs help. It needs the human, ability to give it what it needs. I mean, obviously at some point, maybe it won't, but thankfully we still need that.
Yeah, I think the Python version of what you just said is, I can ask ChatGPT, or I'm probably going to ask Claude AI, because my experience is it just does a better job when it comes to writing Python code. I can ask it to write a simple function to read a log file, to parse out the IP addresses and return back a list of IP addresses, and it's pretty snazzy at that. It can knock that out for me, and I do that, right? That's what I do. Until that function doesn't work, right? And then it gives me back a function that I put into my code, and then it generates an error. And then I take my error message and give it back to the AI and say, hey, it's producing this error. And then it gives me another version and another version, until finally we cycle back around to the original version of the code that I gave it. And you just run into limitations in capabilities. I've been tasked with writing things in languages that I don't know or understand, and used AI to try and write some of them. And ultimately it comes down to, eventually you hit this wall where the AI is writing code that you don't understand. You're running code you don't understand, which sounds like a very bad idea from a security standpoint. I'll just say that. And you get to the point where it's not going to advance any further, and your only option is to really understand the code that it's writing, and what is it doing. I do think AI has a place in every developer's toolbox, but ultimately it's not there where it's going to replace us today. And I don't think we're going to get there for several more years.
Yeah. like you said, making sure that you're using it as an aid. And I've said this before as well, and people probably don't want to hear it, but like I remember when I first got into information security and just I was very hungry. I'm still very hungry on wanting to learn. Always it should be a lifelong passion. But there's a lot of people who get to a point where they just become complacent. They're like, oh, I've had kids now. I'm older. I've got other things. Life's in the way. It's complicated. I don't have the time to do all this. And I think that used to be okay in many cases, in many types of positions. Like you could still ride your career out until you wanted to retire. But I think now, with what we're seeing already in the workspace, I mean, it's really difficult to tell with these tech layoffs recently how many of them are due to politics, due to AI, due to other factors, revenue forecasting, all that. It's difficult to know why that's happening, but you do see a lot of developers complaining online about difficulty getting jobs, especially for new people. So I think that now more than ever, you can't be complacent anymore. You've got like make sure you integrate this technology into your daily work. I mean, automation has always been a thing. Like we're always short staffed. We always want to automate the things we can with PowerShell or Python or whatever. Look at fuzzing. That's automation, right? You're automating the bug discovery process. But yeah, I think that's the end of my statement. But
yeah, I think when it comes to layoffs and reductions in force and things like that, when they look around the team and they start thinking about who they're going to eliminate, the last person to go is going to be the person who can write the tools to replace the other people that they left, that they laid off. So, I mean, having automation and coding skills is a survival mechanism.
Just to give another like example, it's not related to security, but it's related to this technology. I've been in bands my whole life. I'm in a band currently, and we just like released a new video today. And my partner in the band, he's super brilliant guy, and he's been using a ton of AI. And his wife is actually a photographer, and she said that she used to take the photos that she wanted to have edited and she would give it to people and farm that out and they would do the work and get paid for it. And now the AI tooling is so good that she just does batch jobs and it's free pretty much, or she pays a monthly fee to the thing. But like Steve, my partner in the BAM, was using AI to like touch up the videos, to make anime versions of the videos. Like if you ever remember the really old song, like Take On Me, Take On Me, the Aha song. There was like a comic sketch in the video. It was really cool and well done. Now you can just like have it does it instantly to your video. So like all of that's going to replace jobs. So obviously we're not going to be we're going to be vulnerable to that. But I think cybersecurity and keeping up to date with this stuff will really help out with that.
Hey, that reminds me of something. Can I plug something here? So on my YouTube channel, YouTube at Mark Baggett.
Yeah, I'll post it again.
YouTube at Mark Baggett. Last year, I decided I was going to do this thing called the Infotech Toolshed, where I started interviewing people that I wanted to go talk to the OGs in information security that wrote a lot of the tools that pioneered a lot of the attacks and things like that that we use in the industry, and document their origin story of the tools or techniques that they came up with. So I started doing this thing called the InfoSec Toolshed last year. It's been slow going because, yes, AI can help with video editing, but man, I've got a while before I get to the point where I'm good enough to just put these videos together and knock them out quickly. So I think I got like 10 episodes out there, but some of your audience will love them. There's the story of the origin of Back Orifice and Back Orifice 2K, which really, all of the kind of thing like process hollowing and things like that. I think that Back Orifice 2K really originated a lot of those unique loading of processes and process hiding and things like that. So I've got that origin story, as well as the THC scan, THC Hydra. I've got Van Houser on there talking about the origin of THC scan, which is such a fun episode in my opinion. But anyway, origin stories of hacker tools is out there on youtube.com at Mark Baggett. And I might not do any more for 2026 just because the editing process takes so long. And I might wait till I get till the amount of people that have viewed the videos is 1/2 of the amount of time that it takes to edit a video before I write another one. But we'll see how that goes. So check those out. And if you like them, let me know.
Cool. All right. I think it's a good place to pause here. Thanks so much, users of security, for gifting that membership to someone. I appreciate it. Yeah, and like I posted, if you do want to help out the channel, I'm sure you know this, but all proceeds from ad revenue or anything, and it's not much, sadly, but and any membership fees and all that, it 100% of it I use to give back to the community, like we did last year with sending people to DEF CON and all. So again, unfortunately, it's not that much money that comes in. It's like a couple $100 a month, if I'm lucky. But as it accumulates, that's what's going to allow me to do things like giveaways. Like I want to do you saw me ask a question earlier. If I was going to do a giveaway coming up on a stream, would you rather be in the form of a training voucher or a tool or something like a Proxmark or a Flipper? So that's what that goes for. But I did a private video for members a couple months ago. It was on how to patch commercial software. So the protections that they put in to try and make it so you've got a trial of 14 days, trial's expired, and you can't even uninstall and install it again because it does things. How to go in with a tool like IDA and patch it and then get around that stuff. Obviously, I can't post that on YouTube because it's pirating software, so they would take it down. Cool. All right. Well, that's the end of this week's session. I will post soon as far as what we are going to be doing for next week and the upcoming weeks. Oh, last note on that. I was talking to someone named Will Pierce. He runs a company called Dreadnode and has a AI CTF framework called Crucible. And he was the AI red team lead at NVIDIA. So obviously that's a pretty cool place to be if you're going to be a red team lead for AI, NVIDIA's cutting edge technology. And so he's going to come on sometime. I'm trying to get locked down a date. That's the hard part with people, but I'll let you know about that one because I'll be excited to hear from him, who is someone who is obviously super like up to date on all this stuff. And when someone like him tells me there are no experts in AI security yet, I believe him. You know, it's a lot of people have surface level knowledge. It's kind of like when crypto got big and Dogecoin was out, and you couldn't go into an Uber or a Lyft without the driver talking about how much Doge or ETH they had. We're kind of at that point now where we're still like really on the rise with this technology. So, you know, I'm sure we'll get there in terms of security. I live in San Francisco area in Berkeley. And so obviously I talk to a lot of people in the community that work in Silicon Valley, and just talking to developers all the time and them telling me that the code is so not secure. Like it is, it's almost like we don't learn the lessons of the past on things like, hey, where did we go wrong with crypto? There's always vulnerabilities in Solidity smart contracts. And like no one does security at the beginning because they're in a race to get the technology out there. And they're working at, lightly funded organizations and startups and all that. So it's an afterthought. And we're seeing that same exact thing now on the AI side. So we have a course actually at SANS called 535 that's going to be coming out as an alpha next month. And it's going to be 3 days at first, and then it's going to go to 5 days. The first 3 days are focused on offensive AI. So prompt injection attacks and vishing and using AI to write exploit code and malware analysis and all that. And then the 2 days added on to that are going to be on adversarial AI. The reason I brought that up is because the adversarial AI part is all about testing the models themselves, and even down to things like sponge attacks, like a denial of service against Mark's server. But cool. Users, thank you so much. That's really awesome. You gifted 10, or they gifted 10 off by one security members. That's really, really cool. I appreciate that. Hopefully, and like I said, I'm working on merch. And so I've been working with the company. Oh, shoot. What the names? It's the company that does really cool merch for like a lot of DEF CON stuff and everything. Miscreants. So Miscreants is actually making our merch design for free because they like to help out channels that do things like this and give back to the community. And we're pretty close to a shirt and a hoodie. So that'll be coming out, like just tweaking a lot of things, and hopefully you'll like that. And we'll have that available in a store format for people who want to buy it. And again, proceeds are just going to go back to the community. And then for members who have like been signed up for a few months, we'll probably give away t-shirts and things like that. Cool. All right, that's enough. We'll cut it here. Mark, thank you so much for coming on, and love to have you back anytime you want to come back again and share with folks. I know you've got a ton of knowledge that you can do that with, but I know your time is also important.
Yeah, no, I appreciate the opportunity. Thanks for having me on.
Yep, thanks. And definitely check out Mark's InfoSec Toolshed on YouTube. We posted all the links, and I'll post them up under the description when this goes live on YouTube after this. But either way, we will see you next week, and have a great weekend. Thank you.
Bye.